I'm just going to be testing the sound. Okay. So hi, everybody. We're going to be doing 3 separate problems for this. They're all going to be empirical formula of a hydrate problems, but they're going to be presented in different ways. The first way is going to be the way that we practice in class. The second way is going to be very similar to question number 4 on the homework. And then the third way is going to be an introduction to a new way of finding an empirical formula of a hydrate. They're all related. They're all going to be mass to mole situations, and you're going to get the empirical formula the same way. So the first one we're going to do is hydrate of magnesium sulfate has a mass of 13.52 grams. The sample is heated until no water remains. The magnesium sulfate anhydrate has a mass of 6.60 grams. Find the name and the formula of the hydrate. So we're going to begin like we normally begin. We know that we have hydrate. Again, I apologize for my left hand. So we know we have a hydrate, and we know that our hydrate is going to be composed of magnesium sulfate and water. The total mass of our hydrate is 13.52 grams, but the mass of our magnesium sulfate is 6.60 grams. So I'm just going to make a note of that. To find the mass of our water, we're going to drop that calculator. We're going to be doing the mass of the hydrate minus the mass of our salt. So it's going to be 15.52 minus 6.60. So we're going to get the mass of our water. As always, when getting empirical formulas, we have some steps. We are going to go mass to mole, and if we don't have a small whole number ratio, we're going to divide by the small and get the whole. Okay, so our first step is going mass to mole. So we're going to be doing 2 mole conversion problems. I'm going to have my periodic table handy so you guys can see the numbers that I'm using so you know where they come from. So magnesium sulfate first. Magnesium on the periodic table has a mass of 24.31 grams per mole. Then we have sulfur, which is 32.07. And then we have 4 oxygens, which I believe is going to be 64. Let me just double check. 16 times 4. There we go, 64 grams. I'm going to add that all together because that's how we get a formula mass. You just add all the parts up together. I apologize for the glare on this. It's what we have to work with. So we have our molar mass of our magnesium sulfate is 120.38. All those numbers came from the periodic table. Okay. And so to get our mass to mole conversion, it's going to be the grams that were given, which is 6.60 grams. And then that's going to be put into our conversion factor. We are converting from grams to moles, so moles has to go up top. That's our unit. In 1 mole of magnesium sulfate, there is 120.38 grams. And so when we plug this into our calculator, it's really, how many times can I slam this down? So our answer is 0.548 moles. And we're going to work with 3 sig figs today because our problem has 3 sig figs. We're going to keep it as 0.0548. Okay, moles. Beautiful. And now we have to get water. Don't forget your labels, they're very, very important. So now we're going to do water. So water's molar mass is 18.02 grams per mole. We know this because oxygen is 16, hydrogen is 1.01. We have two of them, so it's going to be 18.02. So we're going to plug in our waters for our numbers for water. So it's going to be 6.92 grams multiplied by 1 mole because we are doing a mole conversion over the molar mass, which is 18.02 grams per mole. So then it's really 6.92 divided by 18.02. And you get 0.384. So right now our mole ratio, so I'm going to write step 1 mass. Step 1 is mass to mole. Step 2 is going to be divide by small. So when we're looking at our mole ratio currently is 0.0548. The glare, huh? All right, that's a little better. 0.0548 moles MgSO4 to 0.384 moles H2O. Okay, and so what we're going to do now is we do not have a small whole number mole ratio, so we are going to divide by the smaller amount. The smaller amount is clearly magnesium sulfate because it's 0.05 compared to 0.3. That's a much smaller number. So we're going to compare. Sorry, no, we're not going to compare. We're going to divide. So we got 1 here. So for every 1 magnesium sulfate, how many waters do we have? Let's plug this into the calculator. Seven. Wow, perfect. 7.00. So our empirical formula would be MgSO4.7H2O, and the name of this would be magnesium sulfate heptahydrate. Because if we remember our prefixes from way back when, the prefix for 7 is hepta. So let me zoom out. Don't worry, I'm going to send a picture of this to the remind page too. This is all the work we did. So the first thing we did was we had the mass of the whole hydrate and we had the mass of our salt. So then we got the mass of our water by simple subtraction. Then we did mass to mole. So we divided the mass given to us in the problem by the molar mass from the periodic table or the formula mass, I should say, which is listed out how we did that here. So we got 0.0548 moles MgSO4. Then we did the same thing with the water. The mass of the water also came from the periodic table. So then it was the mass given that we found from our subtraction. It was divided by the molar mass of water on the periodic table. And we got 0.384 moles H2O. Step 2 is divide by the smaller mole when we don't have a whole number mole ratio, which we don't because we had 0.0548 and 0.38. So those are not whole numbers. So we divided both by the smaller. So we got 1 MgSO4 for every 7 H2O. This is our empirical formula. This is our name. Okay, I think I'm going to separate this into 3 parts so that way you guys can watch the whole video and you're not going to get freaked out if it's like a 15-minute long video. So this is part 1, and I'll see you guys for part 2.